Okay, right now I'm going to grade the quiz from yesterday's class period. Number one, the chemical reaction represented by the equation 2NaOH plus H2SO4. In this type of reaction, it looks like we have a compound reacting with a compound. And among the choices, I think that looks how we've always described a double replacement reaction. We don't need to worry about the products here, but what it looks like would happen is the Na plus 1 would switch with the SO4 minus 2, and then the H plus 1 would go with the OH minus 1. So our products would be Na2SO4, because it's a plus 1 and a minus 2, and HOH, which becomes H2O. So this looks like a double replacement again, and then we would go ahead and balance. Number two, the reaction between zinc, which is just Zn, and hydrogen monochloride. Again, we have to be able to name and write formulas. HCl is, this time it looks like we have an element plus a compound, and the positive zinc would switch places with the positive hydrogen. So that looks like a single replacement. Again, an element plus a compound, single replacement. The combustion of, just hearing that word, when I see the word combustion and produces, I'm already thinking CO2 and H2O. Maybe not always the case, but always the case for our examples this year. So we're looking at D there. When CH4 reacts with O2, so let's go ahead and write that. The coefficient in front of the O2 is, I think we have to go ahead and predict our products. Again, this is another combustion, so we're going to get CO2 and H2O. And then we have to balance this reaction to find out what the coefficient in front of the O would be. So again, I think we should start with the carbons. One carbon, one carbon. That's good. 4 hydrogens, 2 hydrogens. We're going to need a 2 here. And now we have 2 plus 2 is 4 oxygens on the product side. We need 2 times 2 is 4 oxygens on the reactant side. So I think we have a 2 is the coefficient in front of the oxygen. Question 5. The balanced equation for the single replacement between copper 2, that'd be Cu, and silver 1 nitrate, AgNO3, is, so it looks like the copper is going to switch places with the silver. Let's go ahead and write the charges here. So we're going to get Cu plus 2, NO3 minus 1. I think we're going to need 2 of the nitrates. And then the silver is going to get kicked out of the group. Okay, now to balance this, it looks like we have 1 copper, 1 silver, 1 silver, 1 NO3, 2 NO3s. We're going to need a 2 here and then a 2 here. And it looks like the products are going to be CuNO3 plus 2Ag. This looks like reaction C there. For number 6, the breaking down of a complex substance to form 2 or more simpler substances, I think that was our definition of a decomposition reaction. Question 7. The type of reaction represented by AX plus BY. Since we have different atoms bonded together both here and here, I'd say this is a compound plus a compound, and for us that was a double replacement reaction. And again, it looks like the positive here is switching with the positive here, so we get AY and BX as our products. Double replacement. For question 8, an example of a double replacement, what I'm looking for here is a compound plus a compound where the 2 positive ones are switching. So let's look for that. Number 1, I would say, is one thing breaking down, a decomposition. B looks like a compound plus a compound and the positives are switching. Let's hold on to that. That looks good for now. C is an element plus a compound. This is probably a single replacement. And then in both D and E, we have 2 smaller substances combining together, which would be a synthesis. So I think we're left with choice B there. There's our double replacement. In number 9, when Al reacts with CuNO3, what are the products with correct coefficients? We need to write this out again. So it looks like we have a element plus a compound, so this is going to be a single replacement. Therefore, we need to think about our charges. Now I know aluminum's a plus 3 because that's where it's located on the periodic table. Sorry about that. Nitrate is written on the periodic table again. It's a minus 1. Since there are 2 nitrates, the copper must be a plus 2. So let's go ahead and predict what goes with what. The aluminum is going to switch places with the copper, so we get AlNO3. But since the aluminum is a +3 and the nitrate's a -1, aluminum nitrate is AlNO3 3. And then the copper gets kicked out of this group. And now to balance the equation, we have 2 nitrates on this side, 3 nitrates on this side. We need to have a 3 here and a 2 here. And then we need to have 3 aluminums, 2 aluminums, and 3 coppers. So I think 3 coppers and 2 aluminum nitrates, that looks like choice D here. Lastly, a jeweler adds AgNO3 to a metal spoon and a reaction is observed. What is a possible conclusion of the jeweler? Now if you added silver plus silver nitrate, I think because the cation is the same here, you would see no reaction. So I would therefore say that this is not made of silver. So A is out. It can't be made of silver if we saw a reaction. Now the object could be made of iron. If we look at our reactivity series, we notice that iron, Fe, is more reactive than Ag. So we could see a reaction there, and I think that leaves us with D. Both B and C are possible.